Welcome to the Worked Solutions for the Unit 10 assessment. In this first question, we have a bedroom floor. All the dimensions are in feet and the intersecting segments are perpendicular. She completely wants to cover the floor with square hardwood tiles, and each tile is 1 foot. No tiles will be cut. How many tiles will Minnie need to cover the floor? Well, we can take this floor and section it off into 2 pieces, which we can calculate the area. We have this first region, the second region. The first region is a rectangle that is 6 by 9. And so the area of the first region is 6 times 9, or 54. Now in region 2, we know the vertical distance is 6. The horizontal distance was part of an 11. Now 6 of the 11 was already used in the region 1, so another 5 remains for region 2. And so region 2 is a 5 by 5 rectangle. Its area would be 25. Total area would be 79. And since these units are in feet already, this would be 79 square feet. Our area on the second question needs to be in square feet, and we're of each shape below. Now in the second shape, because it's in square inches, we're just going to say in square inches. We're just going to find the area in square units. Our first shape is a trapezoid. And the area of a trapezoid is 1/2 times the height times the sum of the 2 bases. The bases are the parallel lines. So in this case, the 2 bases are 18 and 6, and the height is 9. So we go 1/2 times 9 times 18 plus 6. 1/2 times 9 is 24. And when we work this all out, we get 108. So that would be 108 square feet. On the second one, the shape is a kite. In a kite, the diagonals are perpendicular to each other. The formula for the area of a kite is 1/2 diagonal 1 times diagonal 2. Now a diagonal goes from vertex to opposite vertex. So one diagonal would be 8 plus 8. And the second diagonal would be 2 plus 8. 10. So our area is going to be 1/2 8 times 10. It's going to be 40. For the next question, we have to find 3 statements that are true. So out of these 5 statements, 3 of them are true. We have 2 area questions and 3 perimeter questions. So let's just check them out. Let's do the 2 areas first. The area of triangle ACD is 9 square units. ACD is this triangle that I'll highlight here in blue. It happens to be a right triangle. The vertical side is 3. The horizontal side is 6. So the triangle ACD is 1/2 3 times 6, which doesn't equal 9. So this is a true statement. We will use this one. In our second statement, it says the area of triangle ADE is 18. So we look at ADE, ADE, this triangle. Its area is 18. Okay, its vertical height is 1, 2, 3, 4, 5, 6, 7. And the height of this, we go from the vertex to the side. So that is 6. So its area would be 1 times 7 times 6, which is 21. So this statement is not true. So we found one of the false statements, and we can find the other one. The remaining two have to be true. Next, we're looking at triangle AFB. Its perimeter is greater than 10. So triangle AFB, A to F to B. This triangle is bigger than 10. Well, AF is 4. AB is also 4. And since it is a right triangle, this last side is going to be 4 squared plus 4 squared, square root of that, which is the square root of 32. 16 plus 16. Now, square root of 32 is bigger than 5. So I have 4 plus 4 is 8. Something bigger than 5. That perimeter is bigger than 13. So AFB is bigger than 10. It's definitely a true statement. If it's bigger than 13, it's automatically bigger than 10. The perimeter of triangle ABC is 16. ABC is 16. ABC. ABC. Again, we have a right triangle. This horizontal part is 4. This vertical part is 3. And any time we have a right triangle, to get the hypotenuse, we square the two legs. Add them and take the square root of it. So 3 squared plus 4 squared. 3 squared plus 4 squared is going to give us 25. The square root of 25 would be the number 5. So our perimeter would be 4 plus 3 is 7 plus 5. A perimeter of 12. They say the perimeter of ABC is 16. It's not 12. So that means this last statement is also going to be true. And we could check that ourselves to look at triangle or polygon B, C, D, E, F. It would be the very large polygon, pentagon around the outside. And quickly with that, this part is 6. This piece is 7. This piece is 6. We said this up here was 5. And this was the square root of 32 from previous answers. So 6 plus 6 is 12. 5 plus 7 is 12. So there's 24 right there. And this bit throws us over to 24. So that is indeed a correct solution. Moving on to our next question, we want to find the area of this sign. Well, area is 1/2 times height. The base is 10. So the height is this piece here. Well, to find out that piece, we have to use the word triangle I've outlined here. The height is one unknown part. This piece would be 5. So you would be saying 5 squared plus 8 squared equals 13 squared. We'd be using the Pythagorean theorem. 13 squared is 169. Take away 25, it's 144. And one number times itself is 144, that is 12. We'll put in height of 12. 10 times 12 is 120, and half of that is 60. So this area would be 60 square feet. What is the area of the triangle to the nearest square inch? On this one, we have two sides and the angle between the two sides. That's where we use the new formula. 1/2 rho A will be sine of C. 1/2 one side times another side times the sine of the angle between. So 1/2 times 6 times 9 times the sine of 56. Here we pick up a calculator to do our calculation. We end up with 22.384. They want the nearest square inch. That means whole number. And so our answer would be 22 square inches. Here, make sure your calculator is in degrees. Most of them are set that way, but if you have a TI-84, you may double check by pressing mode. And our final question is to find the area of this regular polygon to the nearest tenth, one decimal place. Well, this polygon is going to consist of a total of 6 triangles, all having the same size. These are each 4. So we can find the area of one of these triangles. We'll find the area of all of the triangles. In the center, those 6 angles have to add up to 360 degrees. So if we take 360 divided by 6, because there are 6 triangles, we find that each angle in there is 60 degrees. So the area of one triangle is 1/2 is 4. That's the sine of 60 degrees. Since we have, let's see, 1/2, 4 times 4 is 16. And half of 16 is 8. So one triangle is going to be 8 sine 16. So the whole polygon would be 6 times that, because there are 6 triangles. So 6 times 8 sine 60. Now we can pick up our calculator. We get 41.569. So our answer to the nearest tenth would be 41.6 square meters. Don't need the square there since I have SQ. Make sure you study through these. On Math Excel, there is a group of questions to let you practice how to find areas of flat surfaces. It is not for a grade, but just merely to practice how to go through these particular calculations again. It has question help that can give you aid if you forget to find different areas, their formulas. I strongly suggest you look at that so that you get that practice. Thank you.